Describe experiments to investigate electrolysis using inert electrodes of aqueous solutions such as sodium chloride, copper 2 sulfate, and dilute sulfuric acid, and predict the product. So they're the only ones they're going to ask you, okay? So you can just learn them ones. Now this is based on chemistry of what's called electrode potentials, which is very similar to the reactivity series. So I'm just going to go through a couple of examples for you, and then we can come up with a rule based on it then. Okay, so NaCl, also called brine, is basically sodium ions and chlorine ions, Na plus and Cl minus. Now we're looking at NaCl, but it's aqueous. Okay, so how do we predict what the products are going to be at the cathode and what the products are going to be at the anode? So electrolysis of this solution will lead to the production of hydrogen, chlorine, and sodium hydroxide. So products, hydrogen, chlorine, and NaOH. Okay, so you can just learn that if you want to, okay? Or you can write down both the ion equations and decide what goes where. So the ionic equations are NaCl, aqueous, to give you Na plus, aqueous, plus Cl minus. And then we also have water present in the solution, H2OL, to give you H plus and OH minus, both which are aqueous. Okay, so at the cathode then, so we're looking at the cathode and the anode. At the cathode, sodium and hydrogen will accumulate, so at the cathode. So you can see here at our cathode, sodium and hydrogen are accumulating. Now, the hydrogen is preferentially reduced to produce H2O. So the hydrogen will be reduced to produce H2. So 2H plus give you H2. And then what have we done? We've added back our 2 electrons to make them atomic, and then we've put them together in a covalent bond. So 2H plus plus 2E minus to give you H2. So that's the reaction that takes place here at the cathode, the preferential reaction. Okay, so what happens at the anode? So at the anode, Cl minus and OH minus both accumulate. Cl minus and OH minus both accumulate. So there's a rule here that decides what happens. So the electrode potential for hydroxide is lower than that of chlorine. So when the concentration of chlorine is low, hydroxide is discharged. Okay. So then when the concentration is high, so the sodium chloride concentration is high, the chlorine is discharged. When the chlorine is discharged, what we get is we get Cl minus to give you, 2Cl minus to give you Cl2 plus 2E minus. Now the hydroxide equation is 4OH minus to give you 2H2O plus O2 plus 4E minus. Okay, now this is a bit complicated, isn't it? Right? We just need to learn the rule, I think, really is the best way to go about that. But the reason it happens, it might help you if you understood the reason, is because when the concentration of chlorine is high, chlorine is more easily oxidized than hydroxide. For this reason, industrial electrolysis of brine uses a saturated solution of NaCl. So as long as the concentration is high, we are going to get chlorine. Okay, so we try and ensure the concentration is kept high, so we do get chlorine because it's a more beneficial product, especially when we're trying to extract it to use it in industry and so on. Okay.